Lab-grown diamonds, also known as synthetic diamonds, are created in a laboratory setting using advanced technology. Here is a step-by-step process for creating lab-grown diamonds. Seed crystal selection. Seed crystal selection is a critical step in the process of creating a lab-grown diamond. A seed crystal is a small piece of natural diamond that serves as the foundation for the lab-grown diamond. The quality, size, and shape of the seed crystal will determine the size and quality of the lab-grown diamond that is produced. The quality of the seed crystal is an important factor in determining the quality of the lab-grown diamond. The seed crystal should be free of any inclusions or flaws that could affect the final diamond. Inclusions are impurities or imperfections within the diamond that can affect its clarity and overall appearance. The size of the seed crystal is another important factor in determining the size of the lab-grown diamond. The seed crystal should be large enough to allow for the growth of a sizable diamond, but not so large that it will create an excessively large diamond. The shape of the seed crystal is also important, as it will determine the shape of the lab-grown diamond. The seed crystal should be a regular shape, such as a cube or octahedron, to ensure that the lab-grown diamond will have a similar shape and structure. The color of the seed crystal is also considered during seed crystal selection. If a colorless diamond is desired, a colorless seed crystal will be used. If a colored diamond is desired, a seed crystal with a similar color will be selected. High-pressure, high-temperature process. The high-pressure, high-temperature process is a method used to create lab-grown diamonds that closely mimic the conditions found in the Earth's mantle, where natural diamonds are formed. A small piece of natural diamond, known as a seed crystal, is selected for use as the foundation of the lab-grown diamond. The seed crystal is placed in a small capsule with graphite and a metal catalyst. The capsule is then placed in a machine that applies extreme pressure and temperature. The capsule is subjected to extremely high pressure, typically between 55,000 to 75,000 atmospheres, or 725,000 pounds per square inch. This is equivalent to the pressure found at a depth of approximately 140 to 190 miles below the Earth's surface. The high pressure is applied to the capsule from all directions to ensure that the diamond grows evenly. In addition to high pressure, the capsule is subjected to high temperature, typically between 1,500 to 2,200 degrees Celsius. This is equivalent to the temperature found in the Earth's mantle. The high temperature is necessary to melt the metal catalyst and activate the chemical reaction that causes the carbon atoms to bond together in a diamond crystal structure. The extreme pressure and temperature cause the carbon atoms to break free from the graphite and bond together in a diamond crystal structure around the seed crystal. This process is known as diamond growth. The diamond grows slowly over time, with the carbon atoms attaching to the surface of the seed crystal and slowly building up in layers. Once the lab-grown diamond has reached its desired size and quality, the temperature is gradually reduced to allow the diamond to cool and solidify. The cooling process is carefully controlled to prevent the diamond from cracking or developing defects. After the diamond has cooled, it is removed from the capsule and cleaned. The diamond is then cut and polished to create a finished diamond. The cutting and polishing process involves shaping the diamond into its desired form and polishing the surfaces to enhance its brilliance. Chemical vapor deposition process. Chemical vapor deposition is a method used to create lab-grown diamonds that involves the use of a gas mixture that contains carbon. A diamond seed crystal is placed in a vacuum chamber. The chamber is then pumped to a low pressure to remove any air or impurities that could interfere with the growth of the diamond. A gas mixture containing carbon, typically methane or a mixture of methane and hydrogen, is introduced into the vacuum chamber. The gas mixture is then ionized, typically by heating it with a filament or by using a microwave or radio frequency energy. The ionization process breaks the gas molecules apart into carbon atoms and other compounds. The carbon atoms in the gas mixture attach to the surface of the diamond seed crystal and slowly build up in layers, forming a diamond. The diamond grows slowly over time, with the carbon atoms attaching to the surface of the seed crystal and slowly building up in layers. Once the diamond has reached its desired size and quality, the gas mixture is turned off, and the diamond is allowed to cool to room temperature. After the diamond has cooled, it is removed from the vacuum chamber and cleaned. The diamond is then cut and polished to create a finished diamond. The cutting and polishing process involves shaping the diamond into its desired form and polishing the surfaces to enhance its brilliance. Cutting and polishing. Cutting and polishing are crucial steps in the process of creating a finished diamond, whether it is natural or lab-grown. The rough diamond is first evaluated to determine the best way to cut and shape it. This involves looking at the size, shape, and orientation of the diamond's internal structure, as well as any surface blemishes or inclusions. Based on the evaluation, a plan is developed for cutting the diamond. This involves determining the optimal shape, size, and number of facets, which are the flat surfaces on the diamond that reflect light. The diamond is first sawed into a rough shape that is close to the final desired shape. This is typically done using a laser saw, which cuts the diamond with a fine, precise beam of light. The diamond is then shaped into a round or oval shape using a process called bruting. This involves grinding the diamond against another diamond, which is held in a machine called a bruting machine. Once the diamond has been shaped, it is then faceted by cutting and polishing the facets. This is typically done using a diamond cutting wheel that is coated with diamond dust. The facets are cut and polished one by one, using a series of increasingly fine abrasives, until they are perfectly smooth and reflect light with maximum brilliance. Once the cutting and polishing process is complete, the diamond is thoroughly cleaned to remove any dirt, dust, or polishing residue that may have accumulated during the process. Finally, the diamond is inspected to ensure that it meets the desired standards for quality, size, and shape. This involves using a loupe, which is a small magnifying glass, to examine the diamond's surface and internal structure for any defects or blemishes. Grading and certification. Grading and certification are important steps in the process of creating a finished diamond, whether it is natural or lab-grown. A lab-grown diamond is graded based on the 4 Cs: cut, color, clarity, and carat weight. The cut refers to the diamond's shape, proportions, and symmetry, which affect its brilliance and sparkle. The color refers to the diamond's colorless or near colorless appearance, with the most valuable diamonds being colorless. The clarity refers to the presence or absence of inclusions or blemishes, which can affect the diamond's brilliance and value. The carat weight refers to the diamond's size, with larger diamonds being more valuable. Once the diamond has been graded, it is then certified by a recognized diamond grading laboratory, such as the Gemological Institute of America or the International Gemological Institute. The certification process involves creating a detailed report that includes information about the diamond's cut, color, clarity, and carat weight, as well as other important factors such as its fluorescence, symmetry, and polish. The report also includes a unique identification number, which can be used to track the diamond's history and provenance. After the diamond has been certified, it is important to verify that the certification is legitimate and accurate. This can be done by checking the diamond's certification number against the database of the grading laboratory that issued the report. It is also important to work with a reputable jeweler or dealer who can provide additional information and documentation about the diamond's origin and history.